All right, the next example we have, example 6, is the Squeeze Theorem, which is listed right above here. Same exact theorem from Calc 1, but the Squeeze Theorem in Calc 1 was with respect to continuous functions, but what we already talked about is that if a discrete function agrees with a continuous function at those discrete values, then the limit of the continuous function as n goes to infinity will be the same as the discrete function as n goes to infinity. So we can essentially just take the Squeeze theorem as we know it from Calc 1 and import it here and use it with these discrete functions. It operates exactly the same way. So the game for any time you want to use Squeeze theorem is you have a sequence, let's say a sub n, and that's the sequence that you want to know, does it converge or diverge. Then you find two other sequences called bounding sequences, for they bound the sequence a sub n. Here, the sequence b sub n bounds a sub n from below, and it bounds a sub n from above by the c sub n. So this is like the top sequence, this is the bottom sequence. So if we can show that the lower and the upper sequence converge to the same number, since this a sub n is always sandwiched between b sub n and c sub n, that forces, or it squeezes, that sequence a sub n to limit to the same value, L. Okay, so show that if the limit of the absolute value of a sub n is equal to 0, then the limit of a sub n itself must be 0. Okay, so what I'm going to do here is, first of all, I'm going to take a sequence, a sub n, and then I'm going to argue that no matter what a sub n is, if I take the absolute value of it, this would have to be the same value of a sub n, or it would be bigger. So think about it. If a sub n is the number, let's say for n equals 3, arbitrarily chosen, doesn't matter. Let's say a sub 3 is the number 2. Then is 2 less than or equal to the absolute value of 2? Yes, absolute value of 2 is just 2. And 2 is less than or equal to itself. So that works. What if my sequence term in this case is the number negative 5? Then is negative 5 less than or equal to the absolute value of negative 5? Sure is, because the absolute value of negative 5 is positive 5, and a negative is certainly less than or equal to a positive. So in general, no matter what number you plug in here, no matter what this number a sub n is, it's always going to be less than or equal to the absolute value of itself. Now, using a really similar argument, we can also say that a sub n is greater than or equal to the negative of its absolute value. Again, we can think about this. Choose, let's say, negative 12. Is negative 12 greater than negative the absolute value of negative 12? And is that less than or equal to the absolute value of negative 12? Let's check this out. So we leave negative 12 in the middle alone, and then we simplify the bottom and top. Well, the top simplifies to positive 12. The bottom simplifies to negative of positive 12, so negative 12. Yes, that is true. And you can try a few other examples to convince yourself of this, but it is true in general. So no matter what number we have, so given any number, that number is less than or equal to its own absolute value, and that number is greater than or equal to the opposite of its absolute value. So now that we have this lower bound and this upper bound, I can take a limit. So I'm going to take a limit of each of these new sequences that we created. Oops. And here the limit doesn't change or flip the directionality of an inequality, so we just keep them there. Now using a limit law, I can take this negative in the front and I can pull this negative out front. We can factor out constants from limits, that's fine. We know that from Calc 1. And then if we're told in this problem that the limit of the absolute value is 0, then this means this limit here goes to -0, and this limit here goes to 0. Well, there is really no notion of a -0. -0 is just 0. So here we have 0 and 0 on the outsides. Well, that leaves no room for any other number besides 0 for this limit. There is no real number that is between 0 and 0. The only number is itself 0. So this right here by the squeeze theorem, so the squeeze theorem implies that the limit as n goes to infinity of a sub n must equal 0.